Right, hi guys. Welcome to today's lesson. I apologize for not being able to make it today or for the past 2 days. I was feeling unwell. I should be back tomorrow, hopefully. In the meantime, okay, let's not waste any more time and let's jump straight to today's lesson, which will be about binomial theorem. All right. Before we jump into what is binomial theorem, there are certain content, certain things that you must understand um, that will help you understand better once we go into binomial theorem itself. So before we begin, okay, let's have a bit of recap. Okay, I'm sure you guys have seen this before. A plus b square and a minus b square in last year sec 2 or this year sec 3 even. And as you guys should know by now that if I was to ask to expand a plus b square or a minus b square, we can actually use the special algebraic product to expand a plus b square to get a square plus 2ab plus b square, and a square minus 2ab plus b square if we were asked to expand a minus b square. Right, so when I have power 2, it's quite easy to expand, it's quite straightforward. But what happens if I have a plus b to the power of 3? Or what happens if I have a plus b to the power of 4? Or a plus b to the power of 5? Or for that matter, a plus b to the power of n? What happens if n is very large? What can I do? You realize that if I was to manually expand each and every one of this algebraic expression, it's not that it's hard, but it's actually very tedious to expand each one of them, and it will take quite some time, and if you're careless you'll probably get the wrong answer. Alright, so what can we do to avoid this? How can we save time? Okay, so before we go into that, let's talk about our lesson objectives for today, which will address the issue itself of expanding a plus b to the power of n. Alright, so first of all, we are going to use Pascal triangle. Before we even go to binomial theorem, we are going to use Pascal triangle to expand a plus b to the power of n, where n is a small positive integer. Alright, next then we are going to learn, okay, probably tomorrow, how to use binomial theorem to expand a plus b to the power of n, where n is a positive integer. Please cancel out this small. Alright, let's take a pen and let's cancel out this small. Alright, it's not small. Okay, but positive integer itself. Moving on, we will also be learning how to use this notation. It's not called n exclamation mark, but n factorial, and the bracket n with n and r on top of it. For now, let's call this n choose r. Alright, I will talk about this more tomorrow as well. After we have done that, we will be talking about how to find specific term in the expansion of a plus b to the power of n using binomial theorem. And last but not least, we will learn how to apply binomial theorem to solve problems. Alright, so but for today, we are going to focus on what Pascal triangle is all about. Alright, so before we move on, alright, we go back to the earlier question of expanding a plus b to the power of 3, a plus b to the power of 4, a plus b to the power of 5. But instead of a plus b, we'll use 1 plus b to make our life easier. Honestly, I would have liked you all to do this manually, but to save time, okay, you realize that if I have 1 plus b to the power of 0, anything to the power of 0 is 1, so 1 plus b to the power of 0 equals to 1. If I have 1 plus b to the power of 1, okay, we will just get 1 plus b, and as shown earlier by special algebraic product, we will have 1 plus b square equals to 1 plus 2b plus b square. Now what happens when the power becomes 3 and 4? Alright, if you have done this manually, honestly, if possible, I would like you guys to pause the video at this point of time and try to expand 1 plus b to the power of 3 and 1 plus b to the power of 4 manually. Alright, pause the video and play the video again once you have expanded 1 plus b to the power of 3 and 1 plus b to the power of 4. Alright, so I'm assuming that you guys have already expanded 1 plus b to the power of 3 and 1 plus b to the power of 4 yourself. So if you have expanded correctly, you should get the following results. 1 plus b to the power of 3 equals to 1 plus 3b plus 3b squared plus b cubed. And 1 plus b to the power of 4 equals to 1 plus 4b plus 6b squared plus 4b cubed plus b to the power of 4. So yeah, if you did not get the results, do check your answers. If you have not tried, please do try it yourself. Right, it's a very good practice for your algebraic manipulation itself. Right, so what's so special about this result? Now, if we were to take each and every coefficient of each expressions, all right, okay, for example, for the first one we only have 1, for the second one we have 1 and 1, for the third one we have 1 2 1, 1 3 3 1, and 1 4 6 4 1. All right, these numbers on the surface, it might not make sense, but if I was to isolate them, all right, and I was to arrange it in such a way, you realize that there is some pattern here. All right, there is some pattern over here. Okay, one, you realize that all the sides, all the expansions will always begin with 1, and the next and the end of the expansion will always end with 1. Right, you see, there's 1 1 1 1 1 1 1. So you realize that over here, the next line, if I was to write down the next line, it should be 1. Now, on top of that, you realize that this number here, alright, is actually the result of the sum of these two numbers over here. 1 plus 1 is 2. And similarly, over here, I have this number here, 3, which is the result of this sum of 1 plus 2. And similarly, if I have over here 1 plus 2, I'll get 3. And it goes on to the next row as well. Alright, if I have 1 plus 3, I get 4. 3 plus 3, I get 6. 3 plus 1, I get 4. So you realize this is what we call the Pascal triangle itself. So I mean, if you want to go on to the next line, you will have 1 and 1, of course, it will end with 1. Alright. So what happens here? I will have 1 plus 4 equals to 5. And 4 plus 6 equals to 10. 6 plus 4 equals to 10. And 4 plus 1 equals to 5. Alright, sorry for the bad handwriting. So, with that, alright, you realize that if I was to expand, let's say, for example, if I want to expand 1 plus b to the power of 5, for example, alright, then I don't have to go to a manual, I don't have to go manually to actually work out what is 1 plus b to the power of 5, or rather I can use the Pascal triangle and realize that all these numbers are the coefficients of the expansions of 1 plus b to the power of 0, 1 plus b to the power of 1, 1 plus b squared, 1 plus b cubed, 1 plus b to the power of 4. So this should form the coefficient of the expansion of 1 plus b to the power of 5. So if I also expand this, I should get 1 plus 5. Let me get an eraser for that, sorry. Alright, 1 plus 5b plus, next one is 10, so 10b square, alright, plus, next one will be 10, so 10b cubed, okay, this is bad, alright, plus, next one will be 5, so 5b to the power of 4, and the last one will be plus b to the power of 5. Alright? And we can go on and on and on. Alright? We can actually get the coefficients of 1 plus b to the power of 6 in the next line, 1 plus b to the power of 7 in the next line, and so on and so on and so forth. Of course, this is not just limited to 1 plus b. I can actually expand 1 plus whatever I want. Alright? I can actually replace the b. Let's say if I want to, I can replace the b, all the b's I can replace with, let's say, x, for example. So if I want to, oops, my power 5 is gone. If I want to, I can actually replace 1 plus b with, let's say, x, for example. Okay, so I can replace this with x, 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 and I can replace this with x to the power 5. Okay, so yeah, In fact, if I want to, I can replace each of the numbers with a negative, each of the alphabets with a negative x. So every single thing with x will now become negative x, and so on. Okay. Apologize for the very bad handwriting. I should be getting a tablet soon. Yeah. So in the meantime, trust me, this is the best I can do with a mouse. Moving on. All right. Now, this is one of the questions that I would like to ask you. Okay, we'll get back to this question again tomorrow. What is the total number of terms in the nth row? Now, why is this question so important? If you realize this question, or rather this, sorry, let me get my highlighter out. You realize that this part over here, this corresponds with the coefficients of the terms in the expansion of 1 plus b to the power of n when n equals 0, n equals to 1, and so on. So if I say I'm looking at 1 plus b to the power of 2, for example, then I will have 3 coefficients, which means I have 3 terms. That means that when n equals to 2, I know that there are 3 terms in the expansion of 1 plus b to the power square. So you realize that this question, okay, it's not just about the number of terms in the nth row, but it's also dealing with the number of terms in the expansion of 1 plus b to the power of n. Alright? Now moving. You realize that there's this notation called n choose r over here. So let's what n choose r do is actually key in these following numbers inside your calculator now. Okay, again, pause the video here first. Okay, I'll give you about 20 seconds, 30 seconds, that should be fast. Okay, record down your answer somewhere. Okay, key in this number over here. Okay, n choose r. So 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3, 4 choose 0, 4 choose 1, 4 choose 2, and so on. Pause the video here first. Now, assuming that you guys have gotten your answers, do you realize that there is some similarities with what you have seen before this? I hope you do, because from here, we can actually transform this into this in the form of n choose r. And that means if I want to go to the 8th row, for example, I will have 8 choose 0, 8 choose 1, 8 choose 2, 8 choose 3, 8 choose 4, 8 choose 5, 8 choose 6, 8 choose 7, 8 choose 8. If I want to have the 100th row, just now we were talking about a plus b to the 100, then I can have 100 choose 0, 100 choose 1, 100 choose 2, 100 choose 3, and so on and so forth. And it saves us time. We no longer have to list down every row of the Pascal triangle to find out what the next row is. Alright? Now moving on. Not only that, but you realize that your n in the n choose r actually corresponds to the power of the binomial that you are expanding, and the r actually corresponds with the power of b in 1 plus b to the power of r. Alright, so with that, I hope you have a understanding as to what a Pascal triangle is about. You have an understanding or an inkling of what we are going to do tomorrow, which is to expand your binomials of greater powers. Again, I apologize for not being able to be there physically, but I hope this lesson helps a lot. If you have any questions, do drop me a text, or do drop me an email, or do ask me tomorrow. In the meantime, please remember, you're supposed to complete your practice now 1. So if you've not paused your video and completed the practice now 1, do practice now 1, because again, tomorrow, the randomness shall select one person to present their answers on the whiteboard tomorrow. Thank you, class.